Everyone, welcome to Chemistry 100 with Professor John Nguyen. In this short video, I would like to talk about scientific notations and a few unit conversions. Okay, let's start out with scientific notations. Scientific notation is a very convenient notation for a very small numbers or a very large numbers. You probably have heard that before. For in this example, I want to show you two example. One is a quantity that is really smaller than 1, and notice that if it's smaller than 1, it's going to end up with negative exponents. For example, if you have 0.000125, now instead of writing too many zero, um, scientific notations is great for that. For example, if you have a decimal point, that's where you start, and you want to go to the right 1, 2, 3, 0, and one more. You want to stop at 1.25. That's 4 places, and that's will give you a negative exponent because this is a small numbers, smaller than much smaller than 1. Now you have to stop between 1 and just less than 10, like 9.999, for example. Okay, so you get yourself a notation called scientific notation 1.25 times 10 to the minus 4. On your calculator, you would put in 1.25 ship log, which is 10 to the x, and then you put minus 4. Remember, the minus sign is not the subtract sign. It's either the minus in parentheses or minus slash plus. On another video, I'll show you guys how to use the calculator. Okay, now move on to large numbers, like a lot, larger than 1, especially the one with so many zero and you don't want to write that many zero, you can drop them. So you would start from all the way to the right. If you don't see a decimal point, you start all the way to the right, and that's where the whole numbers. Okay, so you go to the left, 1, 2, 3, 4, 5, 6. And the reason why you stop at 6th place, because that will give you 1.39. Okay, 1.39, and that's right between 1 and 10, just less than 10. Okay, 1.39, and you can drop all the zero. You don't need them anymore. So remember, this is 6 places to the left, therefore, and this is a large number, so the power or the exponent will be positive. Okay, so this is very convenient, and especially when we move on to the next topic, the conversions. As you can see here, we have a few popular conversions. For example, 1 kilogram equal to 1,000 gram. Now you can write this, because it has 3 zero, you can write this as 10 to the 3 power. Okay, 1 kilometers is equal to 1,000 meter, or 10 to the 3 power of the meters. Similarly, you have kilobyte equal to 1,000 byte. Now, for 1,000, it's not a big deal to write 1,000s, but if you have a billion, 1 gram equal to 1 billion nanorams. That's a lot of zero to write. You would have to write 9 zeros. Okay, instead of doing that, you just write 10 to the 9. Okay, 1 meters equal to 10 to the 9 nanometers. All right, and this is the way to write the conversions. 1 gram equal to 10 to the 12 positive 12 picogram. Okay, and 1 meters equal to 10 to the 12 picometers. Okay, now I'm going to take the this opportunity to um, also introduce you a little bit about significant figures. Okay, significant figures, as we talked about that on the first video of chapter 1, are numbers that's important for quantity and accuracy and precision. Okay, now 45.0 has three significant figures because that zero there doesn't tell us any quantity, there's zero quantity, but it tells us the precision. This number is precise to one decimal place. Okay, 1.00, those two zero have no quantity. However, it tells us the precision 1.00 to the second decimal place. That's why we count it. Okay, so that's why it has three significant figures. Now, this number has no decimal places at all. It's a whole number. It's 2021. So strictly just quantity. If we need all these numbers, 2, the 0, the 2, and the 1 for the quantity. Therefore, we have to count them all, four significant figures. Now, however, when you have 100, 100, that might be just an estimate. So only number 1 is counted as significant figures. Now, you can write this. Remember, we just talked about scientific notations earlier. Now, here's the chance to apply it. You can substitute. You can change 100. You can convert that to scientific notations. That's equal to 1 times 10 to the 2 power. And therefore, it has only one. You only need one significant figures. Okay. Now, here's a good example. You start out with 0, so that has no value whatsoever. So we're not going to count that. But starting from 7, 5, 6, 9, 7, that will have 5 significant figures. Okay? And finally, here's another example. Last but not least, the 0 at the beginning doesn't count. Started with 1, that's a non-zero. So that's 1. And then you got a 0, and then a decimal place, and then 2 0, the last 2 0 are for precisions. Okay, so we have a total of 4 numbers, significant figures. Okay, when you run into a scientific notation and you want to count significant figures, only look at the base numbers. Don't look at the exponent. Okay, the exponent just tell you how big the number is. So 1.005, we need all those numbers. Those two zeros are trapped inside the non-zero, so you count them all. Therefore, it has 4 significant figures. All right. Now, let's move on to unit conversions. This actually, I want to put this on the next video. Okay, so thank you for watching. And in the next video, part 3, we'll be talking about unit conversions. Thank you guys. See you guys soon.